Hello everyone, welcome to my YouTube channel. So today I'm going to be looking at biomedical science, hematology and blood transfusion question and answer. So this is going to be part 1. I'll also do the same thing in different departments like biochemistry and microbiology and histopathology. So I thought that this would be the best way to help us to be able to prepare for our interviews, of course having listened to a number of videos as well. Before we continue, my name is Dr. Emmanuel Ogbodo. I'm a biomedical scientist and I'm also a lecturer in biomedical science here in the United Kingdom. So let's look at our question number 1. Question 1 is, tell me about your experience with automated blood group. So meaning that this question is referring to your experience of using analyzer to perform a blood group. So what are the things that you can see there? So I might say, I have a good experience in using automation to carry out a blood group. First of all, with the help of automation, this analysis, it can be very easy, it can be done speedily, meaning that it can help to maintain a good turnaround time. My experience with this is that, I have a good experience when it comes to troubleshooting that analyzer. So I've used a number of analyzers such as maybe IH1000 or maybe AutoVision, or as the case may be, So in each of these analyzers, so I have experience in doing the maintenance. So I have experience in carrying out monthly maintenance on the analyzer, weekly maintenance, and even daily maintenance on the analyzer. I'm also competent in running a quality control on the analyzer before performing the patient sample on the analyzer. So this analyzer, my experience is that they have commercially prepared A cells and B cells, okay? And of course, we can also use the analyzer, the automated as well, to do antibody screening, so which it also has a commercially prepared screening cells. So how it works is that following the spinning of the sample, the sample will then load onto the analyzer, and the analyzer will scan the barcode. Because of the interface between the laboratory information management system and the analyzer is able to recognize the name of the patient that has that very sample. And once it scans it, what the analyzer is going to do, it makes use of what we call ABO card group. It uses ABO card group for the blood grouping, and also it uses IgG card group for the antibody screening. So for the blood group, it's going to pick the analyzer will pick ABO card group, and following the ABO card group, it's going to punch the ABO card group, and once it punches it, it punches each of the wells. That will create an opening in the wells, and once that opening is created, what the analyzer is going to do is to aspirate the whole blood, the cells the red cells that are sedimented following the spinning of the blood samples. So it will aspirate it, and following that aspiration, it will then dilute it, okay, maybe using a diluent or normal saline, and that will then be used. You're now going to pipette maybe like 50 microliter from that very diluted red cells and put in the A cell, in the A well of the ABO group, B well of the ABO group, and the O well of the ABO group. Then it also have a control. That control has nothing. So these ABO group are embedded in it are the antibody that are specific to a specific antigen. For example, so A well has anti-A, that means antibody A, commercially prepared antibody A, and B well has anti-B, commercially prepared anti-B, and O well has resource or antibodies, which is anti-D, and they are all embedded as a gel. That is a forward group. The principle is that since that the antibodies are already embedded, so if the antigen on the red cells of that very patient is specific to that antibody, it will then bind to it. So what it means is that if it is antigen A that is present, it will then bind with antibody A, and that is how we can work out that is blood group, and so on and so forth. Now that is for the forward grouping. In the reverse grouping, what happened is because there's already a commercially prepared A cells and B cells, that means a blood group A cell and a blood group B cells, and they are also in that analyzer. So what the analyzer is going to do, under the reverse grouping, it has A1 well and it has B well. So under the A1 well, it's also going to make a hole there, and then pipette the commercially prepared A cell in that A1 well, and then pipette a commercially B cells in the B well, and then it will now pipette the patient plasma and put in the A1 well, and of course B well as well. And after that, it can then incubate and centrifuge it and then the agglutination will then be measured. And this will be measured the way the analyzer measures it. It measures based on the ability of the cell to float up or to sediment down. So once the cells float up, it shows that it is positive, and once it sediments, it shows that it is negative. That is how it can be able to perform the blood group, both the forward and the reverse group. The same thing also happened in the antibody screening. The only difference is that it uses IgG card grouping. So this IgG card grouping, the analyzer will also make a hole and then prepare maybe the cell 1, cell 2, cell 3 into different holes, and then add the patient plasma and then incubate and centrifuge. And of course, the result will also be the same, whether it float up and float down. So once the cells sediment down, it shows that there is nothing present. That means the antibodies are not specific. Then that will be negative. That means it's negative. But if the cell, float up, okay, that means that it is positive. That means it's been able to detect a specific antigen or a specific antibody. Can I also add that the forward group, like I've said, is detecting the presence of the antigen that is in the red cells, while the reverse group is detecting the presence of the antibodies that is in the plasma. I hope that makes sense. So that's the principle of the automated blood group. Now, why this is important, it's also important to know that there's a number of factors that can affect this very automated blood grouping. Based on my experience, a number of factors like cold agglutinin can affect it, meaning that we may not be able to get a good result. Of course, blood transfusion can also affect it. That is where we can get a number of discrepancy, like something like a dual population. Okay, now things like autoimmune antibodies can also affect it. Okay, in some cases you can have cold antibodies, it can also affect it. Sometimes age can also affect it, whereby with the age maybe you are not able to get a result on the reverse group until you perform it manually. So there's a number of factors that can affect it. But having said that, if everything has been done the way it's supposed to be done, following the result, once the result has been obtained, it can then be released from that analyzer, then it can then be transferred to the laboratory information management system, which we can now have another look on it before finally validating the result. Okay, I hope that makes sense. Now let's look at question number 2. What manual tests have you performed in blood transfusion in the past? What manual tests have you performed in blood transfusion in the past? Now, what you need to know that in most cases in an NHS hospital, the laboratory is computerized, it's fully automated, but that sometimes we do some manual tests. A manual test is things like maybe something like, I did mention like on question 1 that age can affect the reverse group. Sometimes we are not able to get a result on the reverse group. We then have to do a reverse group manually. I hope that makes sense. And in doing the reverse group manually, what you mean that you are going to take the commercially prepared A cells and B cells and put it in a tube, and then add the patient plasma in it, okay, and of course incubate, and then you can now spin it and wait for agglutination. So that's how we perform. So we can do reverse grouping manually. We can also do forward group manually. What if your analyzer is down? You can also do the forward group manually using the ABO card group as well. We can also do something like DCT manually. That means direct cum test or direct antiglobulin test. We can also do it manually. We can also do maybe something like cross matching can also be done manually, and antibody panel can also be done manually. Even antibody screening can also be done manually. Things like hours can also be done manually. So there's a number of things that we can do manually, even though it is automated. Don't forget that even if we can do those things by automated, we can also do them manually. So like I've said, in manual testing, you can pick anything that you like here. You can say something like, I have done a number of manual testing in blood transfusion, ranging from things like blood grouping and antibody screening, antibody panel, cross matching, direct cum test, okay, hours, and so on and so forth. You can even phenotype. You can mention that these are the manual techniques that you've done manually. So you can even say that you've done something like both the card grouping, and also you've also done something like tube grouping in your manual testing in blood bank. I hope that makes sense. Yeah. Question number 3. What would you do if quality control on blood group analyzer fail? Now, this question is the same like other questions that you have. What you're going to do is the quality control sample fail. So what you're going to say, you say, once the quality control in the blood group analyzer fail, I need to investigate what the cause is going to be. Number one, it could be from the quality control sample itself. Number two, it could be from the reagent, or it's possible it could be from the analyzer. So I'm going to investigate the quality control sample. I'm going to check a number of factors, including things like, is it underfilled? Okay, has it expired? Has it been stored at the accurate temperature? Has it been contaminated? Okay, so I'm going to investigate any of this. If it is any of this, what I will do is that I would then have to discard it and get a new vial where appropriate. Now, also with the sample, I'm going to check to make sure that the batch number or the lot number of that very sample is what is on the analyzer. If it is not what is on the analyzer, I will also going to make sure that I queue it in the analyzer and then repeat the test. So in other words, I'm going to investigate the control sample first. Then if I check, if it is not the control sample, then I'll investigate the reagent. I want to check, is it underfilled? Has it expired? Okay, is it the current bag number? How long has it been in use, and all of that? Is the analyzer able to aspirate enough reagent, as the case may be? I'm going to check all of that. The reagent also includes things like maybe A cells and B cells, or even the antibody screening cells like I've mentioned. So I'm also going to investigate, is the reagent contaminated, as the case may be? Maybe has it expired? So these are the things I'm going to investigate, and if it is any of the problem, I'm going to resolve it, then repeat the QC. But if it is not any of the problem and it is not the quality control sample, there's a possibility then that it could be the analyzer. Then I'm going to investigate the analyzer through troubleshooting. This will help me to find out, because sometimes there can be a clot that may block the probe or the channel, as the case may be. So I'm going to do a maintenance, and that will help me to do some flushes on the channels. Okay, do a background check. If the maintenance work, okay, if it work or pass, then I can then repeat the QC, and hopefully that will be able to solve the problem. But however, if I've done all of this and it has not been able to solve the problem, what I will do is that I'm going to report it to the senior member of staff or the manager, as the case may be. I'm also going to put it on the error log of what has happened, and I'm going to report it to the engineer and call them to come and look after it. I hope that makes sense. Yeah. Question number 4. Patient with flag of anti-D. Patient with flag of anti-D need cross-match and group and safe is negative with no antibodies. Would you issue electronically cross-match on patient with historic anti-D or perform full serological cross-match? Now, before I answer this question, the answer really is that once there is any antibodies, the patient is no longer eligible for electronic issue. Okay, what you then need to do is a serological cross-match. It doesn't matter what happened in future, but let me explain this to you. So what happened is that once we detect antibody in any sample, it doesn't have to be anti-D, it can be anti-K, it can be any form of antibodies. Once antibody is detected, we queue it in on our laboratory information management system against the patient. Okay, so what that means is that before we can decide to give somebody blood, we check, does the person has any historic antibodies or any current antibody, as the case may be. So once a patient has an antibody, we flag it up. Okay, so what this question is telling you, if you notice that someone has anti-D, will you still give electronic issue, or are you going to do a serological cross-match? The answer is this. For the fact that this patient has been flagged up for anti-D, meaning that this person have had anti-D in the past, although that the current group and antibody screening suggest that there's no any presence of antibodies. However, for the fact that this person has been flagged up, has had anti-D in the past, the person is no longer eligible for electronic cross-match according to the blood bank guideline. This person will always going to have, we are always going to do a serological cross-match before issuing a blood to this patient, except in a case of emergency. Then that means that a concessional release form can be filled before, and of course a hematology consultant will be notified if we are going to give the blood without cross-match. So, but otherwise, under routinely, once a patient has been flagged with any antibodies, including anti-D, as you are seeing here, even if the blood group and antibody screening is negative, suggesting there's no more antibodies, we are still going to give serological cross-match. That is the only way to issue the blood, not electronic issue. I hope that makes sense. So the answer to this question is that this person is no longer eligible to electronic issue. We always going to do a serological cross-match to be able to issue blood to this patient. Number 5 question. Would you perform test on expired reagent? No other reagent available. This is a simple question. So once a reagent have expired and you've noted that it's expired reagent, you don't perform any test on it. The answer is no, you cannot do that. You need to do your best to see if you can get a reagent that has not expired. Then if you can't and you must do the test, you then need to send it to a nearby laboratory or a nearby hospital, or if you have a site laboratory of your trust, you can also send the sample there. But no way, you should not do any test with any expired reagent. Question number 6. MOH in process. So this is a major hemorrhage in process, but this major hemorrhage has to do with obstetric. That means it has to do with maybe a pregnant woman or maybe someone in the maternity ward. So obstetric. So in a case of obstetric major hemorrhage, so major obstetric hemorrhage in process, meaning that it has been activated, the process has been activated in maternity, need urgent 8 units. Can I say something this? Because I have not said this on my previous video. Remember, in major hemorrhage, once the protocol is activated, I said that the part 1 includes 4 units of rest cell. But when it comes to major obstetric hemorrhage, the part 1 or whatever thing you're going to give has to do is not 4 units of rest cells, it has to be 8 units of red blood cell. Anyway, so in major hemorrhage, in major obstetric hemorrhage in process, maternity needs urgent 8 units of blood. But remember, patient is BROH positive. That means D positive, meaning the patient is B positive. You have only 4 units of B positive blood left. What is your next move? Remember that from this question, you can assume that obviously this person has a current group from the question. If you are not sure, if you have that during interview, ask them, it doesn't mean that this is a current group. So if the patient has a current group, no antibody history, you give the blood group B positive. So the question here suggests to me that there is no any history of antibody and this person has a current group. Therefore, you are going to give that 4 units of B positive. But remember, you need 8 units of what? Red blood cell. So what are you going to do? What will be your next move? That is the question here. You will say, well, I'm going to give the 4 units of B positive, provided that it is K negative blood. So meaning that because any woman within childbearing age must be given antigen K negative. So I will give 4 units of B positive, provided that it is K negative blood. And also, since that is only the unit left in terms of the group specific of the patient, I can give either O positive, I can give either O negative, I can give either B negative, provided that it is antigen K negative blood. I hope that makes sense. So where preferably, I'm going to make sure as well that I give maybe big C and big D and of course big E negative blood. So meaning that my next move here will be either B negative, okay, or O positive or O negative. So whichever way, it has to be antigen K negative, and preferably, of course, have to be big C, big E, and D negative. I hope that makes sense. Okay, so that will be your next move. Right, question number 7. Your colleague is making mistake on bench. What would you do? Would you tell the senior or manager about it? The direct answer is that you would tell either of them. You can tell the senior, you can tell the manager. So, but what I want to tell you is this. It's always important when you give answer to your question, you put more flesh to it. So when you notice a mistake, a colleague is making a mistake in a bench, is a non-conformance. So you need to let them know that is a non-conformance. That means that the standard of the laboratory will be affected. You know, the reliability, the reproducibility, the overall quality of that laboratory will be affected by that very mistake. Therefore, once you notice a mistake, you can actually notify a senior member of staff or you can notify the laboratory manager. Try not to stop there. You can go further to say this will help the senior or the laboratory manager, in most cases the senior, to be able to call this very colleague, to call the colleague and find out why that mistake is the case. And following the conversation, maybe there's a gap in knowledge can be noticed, can be observed, and that will maybe lead to maybe further training, you know, to make sure that the colleague understand. And of course, maybe the competency may then be reassigned. Basically, it will help to know where the colleague can be helped to make sure that in future the colleague will not be making that mistake. So, but the answer to this question is that you can notify the senior or the laboratory manager, but it most likely is going to be the senior because this is a person that might be in the lab with you because the laboratory manager might be in his office. However, if you don't see the senior in the lab, you might then go to the manager's office and let the manager know about about it. And then the manager will then let the senior know about it, and the senior will then call the staff and then discuss with the staff, and that can now lead to maybe future training, or as the case may be. I hope that's the answer to that question. Question number 8. Blood group analyzer is not working during the late shift, and you have to do 10 group from A and C. What would you do? Now, this might look like it's difficult question. It's not. The question is, what is ANC? It's basically talking about antenatal clinic. So basically this is antenatal sample. And once it's antenatal sample, it is not an urgent sample. It's coming from the GP, as the case may be, or antenatal clinic, as the case may be. So it's not an urgent sample. So the problem is not the 10 blood group that you need to do that is from the antenatal sample, antenatal clinic. The problem is the fact that your analyzer is not working. Because in my own opinion, what is the problem is the samples you are going to be getting from the A&E or from the ward that you need to do on late shift, not even the antenatal. Because with the antenatal, if you like, you can actually put the sample in the fridge and it can be done the following day. So if you are to go by this question, it will look like you don't have to worry because it's an antenatal sample. You don't need to do anything. It can wait till tomorrow. It is not urgent. But your analyzer is not working. So if I were you, I would pay attention on the fact that the analyzer is not working. Now, if the analyzer is not working, you need to troubleshoot it and all of that. So how will you answer the question? You say, well, the antenatal clinic is not an urgent sample, and because it's not an urgent sample, there may not be any need to be in a hurry to run this sample. I might decide to put it in the fridge, okay, and then it can be done tomorrow while I try to troubleshoot the analyzers, because I'm more concerned about the sample that may be coming from the A&E, from the maternity ward, as the case may be. So I'm going to troubleshoot the analyzer and see, if I'm able to sort out why it is not working. So from the troubleshooting, like doing maintenance or maybe doing calibration where appropriate, I'm going to do all of that and see if I can be able to bring the analyzer up and running. So once I finish the maintenance, then I can repeat the QC. If it passed, it means that I've been able to sort it out. Then obviously, if I have time, I can do the antenatal sample. But my focus will be on the urgent sample, like from the A&E maternity ward or the labor ward. So I'm going to do the troubleshooting and see if I can be able to bring the analyzer up and working. Now, once I've done that, then I can be able to carry out any test. But regarding to the antenatal clinic sample, is not urgent. It can actually be put in the fridge and it can be done the following day. So I'll focus on trying to bring this analyzer up and running. I hope that makes sense, because I think that this question is trying to know, do you know that with this antenatal clinic, it's not an urgent one, that you need to focus on the fact that your analyzer is not working, and that should be your focus at that time. And of course, if you want to go further, you can say, since I'm on the late shift, if this persists, I will then let the A&E know, let the medical ward to know, so that they can know that the blood bank is down in terms of the automation. So anything I'm going to do has to be the manually. That means anything you need, anything they are going to send to you has to be an urgent sample only. I hope that makes sense. Question number 9. What is DAT, which is direct antiglobulin test? Some people call it DCT, which is direct cum test. What is DAT? Now, the word there is direct. Another word is, an opposite of this is IAT. So IAT means indirect antiglobulin test. What I can tell you is this, for you to be able to understand it very easy, is this. When you say direct in anything, you are measuring something on the red cells. When you say indirect, you are measuring something in the plasma. In other words, when you say direct antiglobulin test, you are talking about the test that will detect the presence of antibodies binding on the surface of the red blood cell. So when you are measuring the antibody that bind on the surface of the red blood cell, that is direct antiglobulin test. But when you measure the antibody in the plasma, that is indirect antiglobulin test. So what is DAT? DAT is direct antiglobulin test. This is a test that helps us to detect the presence of antibodies that may be binding on the surface of the red blood cells. I hope that makes sense. So that's the answer to the question. Okay? Let me add this as well, because this is blood bank. Once a DAT is positive, even though the antibody screening is negative, for you to be able to issue blood to that patient, there has to be a serological cross-match. You must perform a serological cross-match in order to issue blood to such patient. Can I also add something else as well extra? Now, this DAT as well, it can be commonly be performed in a newly born baby, like in maybe a newborn baby, a new net, as the case may be. Because in new net, they may not be able to, their immune system is not yet developed to be able to develop antibody which can be found in the plasma. In other words, you may not be able to detect any antibody in the plasma of the new net. Therefore, when it comes to the new net, remember in the adult we do antibody screening and we do blood group as well. But when it comes to the new net, we do only forward group. We don't do reverse group. Because remember that the reverse group will detect the antibody that is in the plasma. Okay, the forward group only detect the antigen. So when it comes to the new net, we only do forward group. Okay, then we do this DAT, which will now tell us if there is any antibody binding on the surface of the red blood cell. Anyway, you can add that if you get such a question. But anyway, if you get such a question in your interview, but to go direct to this question, direct antiglobulin test is a test that measures the presence of the antibodies binding on the surface of the red blood cell. I hope that makes sense. Yeah. Question number 10. Please investigate antibody panels. What I will say is that go and watch my YouTube, go and watch my video on antibody identification, part 1, part 2, part 3, part 4. You are going to be expert when it comes to antibody identification. What I'm going to say is this. You need to know that once we are doing a routine test in blood bank, we do blood group and antibody screening. So once antibody screening is positive, then we can do the antibody panel. It is the antibody panel that helps us to know the specific antibody that that patient has developed. With the antibody screening, we know that the antibody is present, but we don't know the particular antibody that is present. We may have a clue, but we don't know the actual one. But when we do the antibody panel, we can be able to say, actually, this is the antibody that is present. And remember, once you identify the antibody present, you are going to cross-match blood for the person if the person needs blood. And for you to cross-match the blood, you need that antibody. You need the antigen negative in cross-match. For example, if you identify antibody Dufi A, if you are going to cross-match blood for a patient, you need antigen Dufi A negative blood for that person. Now, let's say you identify antibody Big C and antibody Dufi A, okay, which is on the case of this kind of this antibody here, but I couldn't show you, okay? So the person has antibodies Big C and antibody Dufi A. So in such situation, once you identify such an antibody, if you're going to give the person blood, if you're going to cross-match, you need to cross-match antigen Big C negative and antigen Dufi A negative blood. Meaning, if the person is blood group A positive, you get A positive that is Dufi antigen Big C negative and antigen Dufi A negative and do a cross-match. And if it is compatible, then you can issue that blood. Anyway, we do antibody panel to identify the particular antibody that is present in the patient sample, and that helps us to select, antigen negative of that very antibodies and perform a cross match. And if it is compatible, we can then issue the unit. Here you go. Thank you very much for listening. Hopefully that has been very helpful. I will try to make more video along this line, whether both in histopathology, biochemistry, of course, and microbiology, of course, elsewhere in this hematology and blood transfusion. Okay, so hopefully that will really help you to see the way the question comes and the way I try to answer it. Obviously, there are some places I try to be more detailed. You don't need to do that. You just need to find a comprehensive way of answering such questions. But yes, hopefully you find it very, very interesting. Yeah. So please, can I ask you to subscribe, share, like, and comment? Thank you very much till I come back your way again. Bye-bye.